I'm Sahas. I'm the leader of this group, and we are here to talk about SSD project. So in here we did this project to EverGreenTea project that we found on GitHub, and in there we fixed vulnerabilities that has been occurred in there. So it's a basic de facto management application. So in there I have fixed two vulnerabilities, and Google authentication was done by me. So what I have fixed was cross-site scripting part in here. So do one of them was like this. So the cross-site scripting, it occurs like when we are having a malicious script that we don't know that's running from us, but it's running was done by a third party, maybe a hacker. So to prevent that, there are several methods: input sanitizations, validations, and so many stuff. So in here I have used 2 3 methods to do that. One is I have sanitized my images inputs. Like I can show you. This is my applied fix. I have sanitize my input string when there's a source for the image tag. We can have a malicious script hidden in that without we knowing. So in here, what I did was removing that, and in here there's another vulnerability we caught in here is like the responses has been sent, and in those responses there are data being passed. So if someone catches that, he can get those data. So we sanitize that as well. So these are my fixtures that I have done to prevent those things. I have updated dependencies as well. So when you're updating a dependency, it will have their own security modules integrated with those, and it will give our system more secure. So to the Google part I have done, it has two parts. One is for the login and other is for the sign in. For the sign in part, I have used Google Auth Provider. This is my client ID in Google Developer Console. I have obtain a client ID and a secret key, and from that through the APIs, I'm validating the user's emails, and from that response I'm getting, I'm checking that it is a valid user or not, and then I do the things accordingly. In the registration, I'm getting his name and emails, and in the login part, I'm checking that he's already logged user. If so, he'll be cleanly joined, and if it's not a logged user, new user will be created without having so much hesitation. With one click, he can log into the system. That's the part I will do in this project. Thank you. I'll hand over to my colleagues.
Hello, my name is Hudha Kumar Singh. So my part is fixing the vulnerability problems issued by missing anti-click checking header and information disclosure. So first I'm going to talk about the missing anti-click checking header vulnerability issue. So this vulnerability is exposed by OWASP ZAP application. So click checking is a method that tricks a user into clicking on something different from what they initially see. This usually happens by overlaying a malicious page on top of an authentic or legitimate one. So without the security headers, content can be inserted into an unsafe environment by hackers in this vulnerability. So how do we fix this issue? Usually to avoid missing anti-click checking header, it's very important to implement suitable security headers to minimize the chance of click checking. So this can be done via implementing helmet middleware and then configuring the uh, frame guard action to deny mode. So here you can see the helmet middleware and the frame guard action to deny mode. So this is about the missing anti-click checking header vulnerability issue. So next I'm going to talk about the information disclosure vulnerability issue. What is information disclosure? This happens when an application accidentally make sensitive information available to outsiders or unauthorized users. So this information may include users information or internal system details or even sometimes credentials. So to fix this, first be sure the sensitive data is not visible in the logs, URLs or responses. And to avoid sending details, error information to clients, and instead send a generic error message. So here you can see an example of the fix I've done. So in the previous code snippet, you can see the we are sending a detailed error message, and the fixed one is only has a generic error message. So doing this, we are preventing the information disclosure vulnerability. So that's about my part. Thank you.
Hi, I'm Kivindu. In this project, I had to fix two major vulnerabilities. One is cross-domain misconfiguration vulnerability. In cross-domain misconfiguration vulnerability, web server is set incorrectly to allow unrestricted cross-origin resource sharing. To avoid that issue, we have used post middleware. You can see in this in previous part, we didn't use any uh, specific things. In here, this is the fixed one. This is the allowed origin, specific origin, and allowed method, specific methods, and allowed headers and credentials. Also, we have used limiter to track requests that coming from same IP address. So it also helps to avoid cross-domain misconfiguration vulnerability. Second one is cross-site request forgery vulnerability. In cross-site request forgery vulnerability, malicious websites unintentionally sending unauthorized requests to uh, different websites, and they have authenticates themselves. So to avoid that issue, we had to use CSRF tokens. To generate CSRF tokens, we have used CSURF middleware and session middlewares. In here, you can see index. In here, you can see we have implement CSRF protection middleware, and when we because we are using sessions, we have to false cookies, and we have used that part in here, and we are sending CSRF token to front end. I mean client. So and we all the routes are protected using CSRF protection. And in front end part, you can see we are getting the CSRF token from backend, and we set that CSRF token with our form details. We are sending our CSRF token in our header. So using this method, we can avoid that CSRF vulnerability issue. So those are the major vulnerabilities that I have fixed. Thank you.
Hello, my name is Vijayaratna, and I will be talking about three vulnerabilities in my part, which are X-content type option header missing, information explosion, and improper type validation. So the first one is X-content type option header missing. In here, this would lead to the security vulnerability called MIME sniffing, and it could cause, despite the server provided different MIME types. So this will leads the attackers to fool the browser into reading content in unexpected or dangerous ways. So to prevent this vulnerability, we have to enable the X-content type option knows sniff header into true. So this will guarantee that browser strictly follows the server specified MIME type and reduce the risk of content interpretation vulnerability. So as you can see here, this is the code before the fixing. So as you can see, after the fix, if you see the code, we have used a helmet middleware to set no stiff header to true to fix this vulnerability. So the second one is improper type validation. So in here, basically, what happens is the input data would not match the required data type. So hackers can provide malicious input to break the logic. So this would cause buffer overflow and injection attacks. So to prevent this vulnerability, we can use validations for the all inputs, and we can use the validation libraries in our code to prevent this vulnerability. So in here, we can see the the post method. In this example, the post method, we have used the several validations to for the password generation. So the third one is information exposure. So this would cause what happen is the application unintentionally make the sensitive data exposed to the unauthorized users. So the attackers can use those sensitive data to against users. So this would cause identity theft and data breach and unauthorized access. So to prevent this vulnerability, we have to utilize general error messages and report details rather than exposing details error message to end users. So as you can see in this code, we have used app disable to disable the expowered by header. So that is my part for this project. Thank you.